Alright, so the section we're starting today is 8.2 Pythagorean theorem, and this is how you need to set up your notebook. So if you need to pause the video right now so that you can copy this down in your notebook. Pythagorean theorem, you already know it from middle school. It's a squared plus b squared equals c squared. And it only works for right triangles. So here I have an example where I have a and b as the two sides of the triangle, and c is the hypotenuse. Hypotenuse is going to be the longest side of your triangle. So just put the longest side of the triangle, and it's also, you can also think about it as the opposite side from the right angle. Okay, so every time you have a right triangle, the hypotenuse is always opposite from the right angle. If it's hard for you to tell which one is the longest, you can also tell by that. And then we have Pythagorean inequalities. The reason I write them, it's just like the Pythagorean theorem, it's just that I have inequality symbols, and the reason I write it with the c squared first instead of last like it's over here is because it's easier to remember what kind of triangle it creates. For example, if c squared is equal to the sum of a squared and b squared, then this is a right triangle. And we can also determine if the triangle is not right. We can use these inequalities to determine if it's obtuse or acute. So if c squared is greater than the sum of a squared and b squared, that is obtuse. And if c squared is less, then it'll be acute. Okay, so you could also write it like I have it over here, a squared plus b squared, but then the sign is like it switches, it flips for obtuse, and same thing for acute, it just flips. So it depends on how you write it, if you write c squared first or c squared last. But this will, I write it this way because it's easier to remember. If it's greater, it's obtuse. If it's less, it's acute. But it's up to you. So for example 1, we're classifying the triangle as either acute, right, or obtuse by using the Pythagorean inequalities. And they gave me 3 side lengths. They gave me 3, 6, and 3 square root of 6. First thing you have to do is determine which one is the c. Because remember, c has to be the greatest number, the longest side of the triangle. So I don't know what this is as a decimal, and I'm trying to see if it's bigger than 6. So what you can do is you can just put it in your calculator, 3 square root of 5, and it's gonna give you about 6.7. So then I know that this has to be c because it's the largest number. So this is a, this is b. You could also have it flipped, but the one that matters is c. C has to be the biggest one. So I'm just gonna plug it into my inequality. And I'm gonna put a question mark on top because I don't know if it's going to be equal or greater than or less than. So I'm gonna plug in my numbers. C is 6, or is 3 square root of 5. Do not plug in the decimal. We just wanted the decimal to know if this was the largest number. You have to keep the radical because we want exact answers. We don't want any decimals. So I'm gonna have 3 square root of 5 squared equals, the a is 3 and the b is 6. So I just plugged in, and I'm just going to evaluate each side. So remember, 3 squared, that is 9, and then times 5, that's 45. If you forgot how to do those, remember this is, we can rewrite it. I'm just gonna show this extra step in case some of you guys are still struggling with multiplying radicals. So wrote it down twice. I'm going to multiply the numbers that are outside. 3 times 3 is 9. And then square root of 5 times square root of 5. That's 5. And so that's how I have 45. 3 squared, that's 9. And then 6 squared, that gives me 36. And so now I'm just going to add the two numbers. Here I have 45, and here 9 plus 36 is also 45. So because these two numbers are equal, I can classify this as a right triangle.